Bismillahirrahmanirrahim and Assalamualaikum and good morning, good afternoon and good evening. It depends when you're watching this video. So today me and my group will be presenting about the application of differentiation. So before we start things off, I want to introduce ourselves. So we are from class RCS 1432A and our group name is Burgundy. So burgundy, like the color, right? So this course is called MAT183 and we are taught by Sir Teo Kim. So our group members are Muhammad Akil Fakrullah, secondly Ahmad Lutful Hadi, and lastly, which is me, Muhammad Daniel Azmi. So the definition of derivative. Differentiation in mathematics is a process of finding the derivative or rate of change of a function. In contrast to the abstract nature of the theory behind it, the practical technique of differentiation can be carried out by purely algebraic manipulations using three basic derivatives, four rules of operation, and the knowledge of how to manipulate functions. So below here there's an example of a derivative of fx with respect to x, is saying that how to define f prime essentially. So the reason as to why we're using differentiation is it allows us to find the rate of change, which is what we're trying to find, and it also helps us determine the maximum and minimum values of a particular function, and also to help us calculate and predict something with more precise and more accurate. So like it helps us calculate more accurately and precisely. So it's like very good. So the application of derivative in daily life, there's a lot, but we're just going to narrow it down. So one of them is to check temperature variations, to calculate the profit and loss in business using graphs, and also to determine the speed or distance covered, such as mile per hour or kilometer per hour. The third one is what people use to calculate the time of the travel scale. So related rates. Related rates are rates of change associated with two or more related quantities that are changing over time. If two related quantities are changing over time, the rates at which the quantities change are related. For example, if a balloon is filled up with air, both the radius of the balloon and the volume of the balloon are increasing. So that is the rates which the changes of the quantities are related, if you get what I mean. So why do we use related rates? In many real-world applications, the associated quantity changes over time. There are many situations and problems that can be solved and calculated using differentiations. For example, inflating a balloon, like I just said, because there's a rate of change of the air inside the balloon. A snowball melting is the same. The rate of change when the snowball decreases in size. Or water draining from a fuel is the same thing, because the rate of change when the water goes out of the Tupperware or the tank, essentially. So I'm going to pass it over to Akil, and he'll be explaining about the problem statement.
On Fridays, usually Muslims will go to the mosque to perform worship, that is Friday prayers, and usually every mosque must have a tank of water for take wudu. This tank also has a rate of change over time, whether it will increase or decrease. So our problem statement is water in the water tank in the front mosque is always used to take a wudu. That water tank is a cylinder figure with a diameter 1.47 meter and a height 2.14 meter. If the water flows out of the tank rate of 0.036 meter cube per minute, how fast is the depth of the water decreasing when the water is 1.5 meter deep? So this is our solution.
Next, we will move to the problem solution. From the problem statement before, we can abstract the information such as diameter for the water tank is 1.47 meter and height of water tank is 2.14 meter, and the rate of change in the volume is negative 0.036 meter cube per minute. It negative because it's flow out. And then we must search rate of change in the height when h equal to 1.5 meter. So I just made first equation, that was dh over dt equal to dh over dv times dv over dt. First of all, volume of cylinder is pi r square times h. It have two variables, r and h, radius and height. For radius, it will be diameter per 2. So 1.47 over 2 equal to 0.735 meter. Then express v in terms of h because dh over dv is need. I will use ratio between radius and height, so it will be r over h equal to 0.735 per 2.14, and the answer will be r equal to 147 per 428 h. And then I'm substitute r equal to 143 per 428 h into v, and there will be v equal to pi times 147 per 428 h square times h, and then we will get 0.118 pi h cube. And then I derivative volume with respect to h, so it will be 0.354 pi h square. From the first equation, I make dh over dt equal to dh over dv times dv over dt. I can take dv over dh to be dh over dv with 1 per 0.354 pi h square times negative 0.036, and we will get negative 6 per 559 pi h square. When h equal to 1.5, it will be negative 6 per 59 times 1.5 square times pi, and the final answer and equal to rate of change in height is negative 0.0144 meter per minute. That was the rate of change in height h.
Now we are at the end of the video. So this is our conclusion for this group project. Knowledge in differentiation such as calculating and predicting something more precise and more accurate can be applied in real life, like calculate related rates. Truth be told, we can practice techniques of differentiation in various fields such as engineering, science, and business. Lastly, our group member wants to thank our lecturer, which is Sir Teo Yong Kim, for the educating us about the accurate way to apply in differentiation in real life situation, and also helping us to finish this assignment in every possible aspect. Okay, that's all from our team. Thanks for watching.